Hey y'all, it's me, Miss B. Today we're going to be talking about complex numbers. Here are some of our goals: to add and subtract complex numbers, to multiply and divide, perform operations with square roots of negative numbers, and then solve quadratic equations with the complex imaginary solutions. Alright, so let's first talk about the standard form of a complex number. The standard form of a complex number is a plus bi. So a and b are real numbers, and a is going to be the real part, and bi is the imaginary part. Okay, so you might be familiar with this, but this is the wheel for imaginary numbers. So we have I at the top, and then we have I squared, which is the same thing. Well, first let me define what I is. I is the square root of negative 1. So then I squared is the square root of negative 1 squared, which is just negative 1. We have I to the third, which is the square root of negative 1 to the third. So that is going to be negative 1 squared times the square root of negative 1. So this ends up being negative I. And then I to the fourth is equal to negative 1, I wrote that wrong, the square root of negative 1 to the fourth, which is negative 1 times negative 1, or 1. The reason why this is a wheel is because it just keeps going around and around and around. So if we had, let's say, I to the ninth, for example, I to the ninth is the same thing as I to the fourth times I to the fourth times I to the first. So that's an exponent rule. We can add our exponents together. 4 plus 4 is 8, plus 1 is 9. And then I to the fourth is equal to 1. 1 again. And then I to the first is just I. So I to the ninth is the same thing as just I. So, or we could count it this way. So here's 1, 2, 3, 4, 5, 6, 7, 8, 9. So that right there is how we get that answer. We wouldn't want to count all the way around for every single problem. So if we have something like I to the 3,000, let's have 2003. The way that we would do that is we would say, we would just do 2003, this up a little further, 2003 divided by 4. So this is going to give us 5. So 5 times 4 is 20. So then we get 0, 0, remainder 3. So 500, remainder 3. So it's going to go around the circle 500 times and then stop here at 3. So this is the same thing as I to the third, or negative 1. So that'll save us a lot of time in the long run if we know how to solve that out. So we just divide, and our remainder ends up being our exponent. Alright, so let's go ahead and jump to how we're going to simplify these. So we want to distribute this invisible negative 1 through. So we get 2 plus 3i minus 4 minus 7i plus 12 minus 2i. Then we want to combine like terms, so our i's are going to go together and our not i's are going to go together. Don't forget that negative on that 4. I'm going to highlight it, just be careful. So then we get 2 minus 4 plus 12 is 10. And then 3i minus 7i minus 2i is negative 6i. And that is in the form a plus b I. So this right here is our answer. So it's just a matter of combining like terms. Same thing with multiplication. We're going to multiply and then combine like terms. So here we just distribute the 3 through. We get 12 minus 6i. The operations are the same. That is our final answer. Go ahead and do this next one on your own. What you should have got was 8 plus 6i. Let's actually make a little bit harder of a problem. So there's that answer to that one. Let's go ahead and do 4 plus 3i squared. So the way we would do that is we would want to split this up. So we'd have 4 plus 3i times 4 plus 3i. So then we have to distribute that through. So we get 16 plus 12i plus 12i plus 9i squared. So we want to combine like terms, so we get 16 plus 24i plus 9i squared. If you remember, I squared is equal to negative 1, so let's go ahead and write that. 16 plus 24i plus 9 times negative 1. So we get 7 plus 24i as our solution. All right, moving on here, we're going to talk about complex conjugates. So two complex numbers that can be multiplied to produce a real number are complex conjugates. All right, they are going to have a real part and oh wait, that's not right. They are going to have the same real part, and they're going to have opposite imaginary parts. So, for instance, if we had a plus bi, a would stay the same, and then bi would be negative. So, if we're looking at the conjugate of 5i plus 3, let's go ahead and write that as 3 plus 5i first in the correct order. So then this conjugate is 3 minus 5i. So that is the conjugate of 5 plus 3. All right, the reason why we want to have complex conjugates is illustrated in the next problem here. So let's go ahead and solve it. So 4 times 4 is 16 minus 4i plus 4i minus I squared. So all I did was FOIL this out. All right, what ends up happening is these cancel. We're left with 16 minus I squared. I I squared is equal to -1, so I have 16 minus -1, which is equal to, I'm running out of room, equal to 17. So 17 is the answer to this very complex thing. So by multiplying by the conjugate, we get rid of the i's. So this is going to be important when we have denominators, because we can't have complex numbers in the denominators. It's a no-no in math. So I'm kind of getting ahead of myself here. So our denominator is 2 minus 5i. So our conjugate of the denominator would then be 2 plus 5i. And so this already says what I said, but in order to rationalize the denominator is multiplied by its conjugate, which is why it's important to know how to find the conjugate. Okay, so we're going to multiply by, I'm going to zoom in here. Sorry, you can rewrite if you need to. I'm going to multiply by 2 plus 5i on the top and on the bottom. We're allowed to do that because 2 plus 5i over 2 plus 5i is the same thing as 1. Okay, so going to multiply that through. We need to make sure we distribute on both of these. So first we'll do the numerator. We'll do 4 times 2 is 8. 4 times 5i is 20i. Then 3i times 2 is 6i. And then 3i times 5i is 15i squared. To the denominator, we get, make this pen a little smaller, we're going to do 2 times 2 is 4. 2 times 5i is 10i. Negative 5i times 2 is negative 10i. And then negative 5i times 5i is negative 25i squared. Not done yet. We still want to simplify, so let's just go ahead and do it as we go. So we were going to have 8 plus 26i plus 15i squared. We're going to keep an eye on that I squared because we can simplify that. Then in the denominator, we're going to have 4 minus 25i squared. Again, got to keep an eye on that I squared. We get 8 plus 26i minus 15 because I is equal to negative 1. So we have 4 minus 20, I'm sorry, that changes to plus 25. So we have 8 minus 15 is negative 7 plus 26i, and 4 plus 25 is 29. So this right here is our new rationalized thing. So this and this 4 plus 3i over 2 minus 5i, they're the same thing, but this is a nicer version of it, where we have a rationalized denominator by multiplying by the conjugate. So it's a much cleaner way of writing that equation or expression. All right. So just a note here, we cannot use the rules that we use to simplify real numbers when there are negatives under the square root. We have to simplify using the principal square root. Principal is with PLE, not PAL. So here are some examples of that. All right, so we've got negative 12, the square root of negative 12 plus the square root of negative 27. So I can't just add those together. I have to break it down. So I'm actually going to write the square root of negative 1 times the square root of 12. That's an okay move. Plus the square root of negative 1 times the square root of 27. So that's completely legal because when we multiply stuff underneath the radical, we can just combine those together. We do want to break 12 into two things, so I'm going to find a perfect square that divides 12 and a perfect square that divides 27. So perfect square that divides 12 is 4, and 4 times 3 is 12, so I'm going to have this whole thing, negative 1 times 4 times 3 is equal to negative 12, so this broken up is the same thing as this. Then on this side, 9 is a perfect square that divides 27, and 9 times 3 is 27, so that is an okay thing to do. So then I'm going to simplify. So negative 1 is the same thing as I, and 4 is the same thing as 2, so I'm going to have I times 2 times radical 3 plus I times square root of 9 is 3 times radical 3. So I have 2I radical 3 plus 3I radical 3. And then now, because I have the same square root, I'm allowed to add these two things together. So 2I plus 3I is 5I, and then we tack that radical 3 on it. So this right here is our final answer. You can skip steps if you feel comfortable, but if you are getting familiarized, then I would not. I'm going to show all of my work, so for those of you that need it, have it. Go ahead and let's actually change this problem to multiplication. So this is going to be negative 5 times square root of negative 5 times square root of negative 8. So what we're going to do is multiply negative 5 and 8 together, and I get positive 40. Perfect square that goes into 40 is 4, so square root of 4 times the square root of 10. So we get 2 radical 10 as our answer. Let's go ahead and do a subtraction problem. Let's do square root of negative 3 minus the square root of negative 32. Yeah, that's a good one. Okay, so square root of negative 3, I can rewrite that as square root of negative 1 times the square root of 3. And then this as the square root of negative 1 times the square root of 32. Can't break down this one anymore, so I'm left with, we can go ahead and write this as I radical 3. When we write the square root, break this down, we want to find the biggest number that divides 32. 4 divides 32, but also there is a bigger square root, 16, that divides 32. If we don't do that, we won't get the right answer. So we have to do the biggest perfect square to divide it. So the square root of 16 times the square root of 2. So we get 4I radical 2 for that. Because I do not have the same thing under the radical here, I cannot simplify it anymore. So this is my final answer. All right, we're throwing it back to the quadratic formula. You need to have this memorized. So if you don't remember, sing that little song. I don't know it well, but it's going to be x is equal to negative b plus or minus. Let's go ahead and use this as our fraction bar since it's here. That didn't quite work. Let's do. So there's our fraction bar. So we're going to say negative b plus or minus the square root of b squared minus 4ac all over 2a. So the ugliest 2a. Alright, so we're going to use a quadratic formula, and we will have some ugliness as far as complex numbers in there. We're actually going to skip the first one for now and jump to number 2 because it's a little bit more complicated. So here's my A, here's my B, and here's my C. Don't forget those negatives. So we're going to get x is equal to negative negative 2 plus or minus square root of negative 2 squared minus 4 times 3 times negative 2. And that is all over 2 times 3. We're going to do this by hand, so we get 2 plus or minus 2 squared is 4 plus 24 all over 6. Keep simplifying here. We get 2 plus or minus square root of 28 over 6. Okay, so because of this plus or minus, it's going to get broken into 2 different parts. So we're going to have 2 plus radical 28 over 6. Oops. And 2 minus radical 28 over 6. So when we do that, we have to break it into 2 parts. So it's going to be 2 over 6 plus radical 28 over 6. 2 over 6 is the same thing as 1/3. Radical 28 is the same thing as, that's 2, it would be square root of 4 times the square root of 7. So it's going to be 2 radical 7 over 6. So then we get 1 over 3 plus radical 7 over 3. Then for the denominator, it's the same thing. We get 2 over 6 minus 2 radical 7 over 6, which is the same thing as 1 over 3 minus radical 7 over 3. So these are the 2 answers that you get. I'm actually going to highlight those so they're a little bit nicer. Okay, so that was just an easy one. We do want to try one where we do get a not real answer. So let's go ahead and do this next one. I'm going to kind of rush through it here. So we get x equals negative b plus or minus square root b squared minus 4ac all over 2a. Wait. Hey, I'm doing a video. What's up? I'll just cut it out. Yeah, I'm still here. Are you leaving? What? Gotcha. I'll come over as soon as I'm done with this. I'm doing the quadratic formula. It's loads of fun. Okay, so then it's going to be 2 plus or minus square root of 4 minus 8 over 2, which is 2 plus or minus square root of negative 4 over 2. You can change it to a what's it called? A complex number as soon as you want to. I'm going to do it right now just so we have it. So then we have 2 plus or minus 2i, because the square root of 1 is I, square root of negative 4 is 2 over 2. So we get 2 over 2 plus or minus 2i over 2, which is then 1 plus I. And, oops, I messed up. 1 plus or minus I. And I'm just going to go ahead and leave our answer like that for all intents and purposes. Alright, that's the end of today's video.